Question 2 in this assignment, I'm just taking this right out of Atkins, good book, 20b.3. So you can see here it says apply the data below to the formation of urea. Initially you have 22.9 grams of ammonium cyanate was dissolved in water. Determine the order of the reaction. Find the rate constant in this. Notice how this does not give you in the data any reaction rates themselves. So the first question, you were given measured reaction rates, and that was one way of finding the order of reaction. This is a bit different. All you're doing is watching this disappear, the amount, over time. So basically what you're going to do with this is trial and error, really, is what you're going to do. So I'm going to walk you through, and it's not super obvious. And if you jump to the answer solution manual, they put a little bit too much emphasis on the half-life thing. When in the end, and when you look at the next question coming after this one, they basically say in the solutions manual, by the way, you're just going to try to get a straight line fit for 0, first order, second order. So for this type of question, you basically try and fit to 0th, first, or second order. What does this mean? So let's just quickly go through it. If that reaction followed 0th order kinetics, if it did, then it would look something like this. The rate equals some constant. It's not dependent on the concentration, but we know the rate, if you have something like A forming products, right? This rate is you're watching the change in A dt, and it's a negative because it's a starting material that's diminishing rate of consumption. So we can isolate this out, so you get this equals K dt. I don't know, I could put the negative over here for now, I guess. And when you integrate this, so now we can integrate this from A naught to A and integrate this from 0 to some time. So this one's just going to be literally, like this is concentrations, right? So this dA integrates to this, subtract that. So whatever the concentration of A is minus the concentration of A naught initial equals negative KT, right? Well, what does this say? If you were to graph this, this comes over to this side. Plus A naught. So it looks to me like you have a negative slope. This is mx plus b. So you're starting at some initial concentration and it does this. So in other words, if you were to plot the concentration versus time, do you get a straight line? And if you do, then it means it's 0th order. And then the slope would equal k. That's literally what you would do. So for instance, so this is the first thing I did. And this is what I expect you to do. Where the hell is it? All right, here we go. So this is what I get when I literally plot the data that question gave you, the concentration of A versus time, and you can see how clearly it's not a straight line, it's a curve. So this would be 0th order. So it's obviously not 0th order. Tried that. So then you say, okay, didn't work. Let's go to first order. And for first order, you would find here. First order would have some dependence on the concentration of A. And if you're watching it like this, dt equals negative K A, and that would be, this had a negative. I'm going a little bit quick here because you've already seen this and should know it. Right? Concentration of A equals negative K dt. So when you integrate this one, you already know you're going to get the ln of A minus the ln of A naught equals negative K T. So in this case, now I'm not sure which quadrant this is. Think about it for a second. Ln of A is going to equal negative kt plus ln of A naught. So the ln of A, when time is 0, is going to equal the ln of A naught. Well, you're going to have something that clearly, now let me see. I'm taking a peek. Yeah, you might have something that, it maybe looks like this, something like that. This will be the ln of A naught, right? But if first order kinetics is being followed and you plot ln of A versus time, you should get a straight line like this, and the slope will be k, right? So what does it look like when I plotted ln of A versus t, questioning is this first order? Clearly it is not. It is not a very good fit at all. 0.944, no good. So it's not first order. That's not working. So now we start thinking, oh my God, where's this going? So now you go to one of the other common ones is second order. And for that, you know that if it was second order in A, you would have your rate being the constant, maybe A to the 2. So now negative d A dt equals k. And then d A squared equals negative kt. When you integrate this, it's going to integrate up to 1, so the integral of x to the negative 2 dx. You integrate that, you get x to the negative 1 divided by negative 1. So you get a negative 1 over x. So for that one, you will end up with, and it's in your book, you're not. So for this one, you're going to get a straight line where you're plotting 1 over A versus T, and you should get a straight line like that. This would be your intercept, and then K will be the slope of that line. So if you plot 1 over A versus T, do you get a straight line? Survey says, yeah, it works good. You get 3 nines. So obviously 1 over A versus time gives it so you have trial and error, if you will, following what I just showed you. It proves that this has to be second order in A for this question. In the book, they do babble quite a bit about taking a look at the half-lives and blah, 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 and this formula only works for everything except first order, right? This is kind of nonsense going away because at the end of the day, you do trial and error anyway, and don't be, everything you did there, you have to have your table of results of trying this, right? So I don't have to really make a video for the next question because it's just like this. They give you data, you trial and error, 0 first, second order, and you'll be able to prove for the next question in the assignment the same type of thing.